Now let's find the centroid of the region bounded by the curve y equals the square root of 25 minus x squared and y equals 0. Let's start with this first boundary here. We can square both sides to get y squared is 25 minus x squared. And so x squared plus y squared equals 25. So this is part of the circle of radius 5. And in fact, it's the upper half, because since y is a square root, y ends up having to be positive. So the region D is this half of a disk right here. Now it's going to be more convenient for us to use polar coordinates as we go forward. Since this is bounded by a circle of radius 5, that means that the range of r values is from 0 to 5. And the range of theta values, since I hit all the points in the first and second quadrant, that's going to be from 0 to pi. Now to find the centroid, we first need to know what the area is. And for some regions, you end up having to do a double integral for that. But this region is half of a circle, so we know what the area is. It's going to be 1/2 of pi times the radius squared. Now we have to find x bar and y bar. X bar is 1 over the area times the double integral of x on this region. And I'm going to do this out, but let me tell you in advance, I already know what x bar is going to be, because there's some symmetry here. We should find that x bar is equal to 0, because x bar is telling you what the average x-coordinate is, and in a region like this, which is symmetric around the y-axis, every point on the left side has a corresponding point on the right side that kind of balances it out, and so the average x value should end up being 0. But let's just do it out in case you find that explanation not quite satisfactory. Now, I want to use polar coordinates to set this up. So instead of taking x dA, what we're going to do is convert x to r cosine of theta. And then remember, dA becomes r dr d theta. We had r was from 0 to 5, and theta was from 0 to pi. Well, that r and that r give me a total of r squared. And when I integrate that, you're going to get r cubed over 3 times cosine theta, where r goes from 0 to 5. Okay, so that gets you 125 thirds of cosine theta. And so now you have 1 over the area times the integral from 0 to pi of 125 thirds cosine theta, d theta. Well, the integral of cosine is positive sine. But now we have to evaluate sine of theta at pi and at 0. And in fact, sine of pi and sine of 0, those are both 0. So that's how we know that the x-coordinate of the centroid, in fact, is 0. Now let's find the y-coordinate. I'm going to just erase a little bit of my work here because the calculation starts out at least very similar. So if I'm going to find the y-coordinate, we're going to start off with a bunch of y's. I'm going to just erase all the y's and the signs, rather all the x's and the signs. So y bar should be the integral of y dA, and y is r times sine of theta. Just let me get rid of this part right here. Okay, so the integral of y, I still get r times sine theta times r. So this r squared all works the same way. That becomes r cubed over 3 times sine of theta. And so we get down to this last part here. The integral of sine is a negative cosine. Well, now cosine has non-zero values at these things, so let's be careful here. We have negative 125 over 3a, combining those first two terms. Cosine of pi is negative 1, and cosine of 0 is 1. So negative 1 minus 1, that's in fact negative 2. So negative 2 times negative 125 is a positive 250. So 250 divided by 3a. And remember, a is this 25 halves of pi. So we end up with 250 over 3. And then dividing by a is the same thing as multiplying by its reciprocal. So 2 over 25 pi. And now we just have to simplify things down. Looks like that becomes 20 over 3 pi. So that's what y bar is. And so to summarize, we had that x bar was 0, and y bar is 20 over 3 pi. And it can be useful to just kind of sanity check our y bar here. So 3 times pi is a little more than 9, and 20 over 9 is, 2 and some change. And if you look at your region, well, the highest point appears at a y value of 5. Exactly halfway up would be at 2.5. But notice that our region is kind of bottom heavy. Right, there are more points below the halfway point than there are above it. And so that should cause y bar to be lower than this absolute halfway point. And indeed, 20 over 3 pi is less than 2.5. But not a lot less. So that sort of passes our quick sanity check for the centroid.